Welcome to our channel. Today, we're going to explore two fundamental concepts in physics, density and relative density. You'll learn what they are, how to calculate them, and why they are important in everyday life. Have you ever wondered why some objects float in water while others sink? The answer lies in the concept of density. Density is a physical property that tells us how much mass is contained in a given volume. It's defined as the ratio of an object's mass to its volume. The formula for density is density is equals to mass over volume. So, if you have two objects with the same size but different masses, the one with more mass packed into the same volume will be denser. Take a metal cube and a wooden block. If they are the same size, the metal cube will be denser because it has more mass packed into the same space. Let's break it down. Mass is the amount of matter in an object, and volume is the amount of space it occupies. Think of it like a sponge and a brick. They might have the same volume, but the brick has more mass because it's denser. The unit of density depends on the units of mass and volume. In the International System of Units, that is SI, mass is measured in kilograms and volume in cubic meters. So the unit of density is kilograms per cubic meter. Let's calculate the density of the block of wood. We know its mass and volume, so we can plug in the values. Density is equals to 50 kilograms over 0.1 meter cube, which is equals to 500 kilograms per meter cube. And that's it. The density of the block of wood is 500 kilograms per meter cube. Now, let's try another example. Can you calculate the density? Pause the video and try it out. Now, let's talk about relative density, sometimes called specific gravity. Unlike density, relative density is a ratio. It compares the density of a substance to the density of water. Water has a density of 1 gram per cubic centimeter at 4 degrees Celsius. So, if an object has a relative density greater than 1, it will sink in water. If its relative density is less than 1, it will float. For example, if the relative density is greater than 1, the substance sinks in water. If it's less than 1, it floats. Think of it like having a cork and a rock. The cork floats because its relative density is less than 1, while the rock sinks because its relative density is greater than 1. To calculate relative density, we use the formula. If the density of the object is higher than that of water, the relative density will be greater than 1. If the density is lower, the relative density will be less than 1. Let's calculate the relative density of the metal. We know its density and the density of water, approximately 1000 kg per meter cube. Relative density is going to be equals to 8000 kilograms per meter cube over 1000 kilograms per meter cube, which is going to be equals to 8. The relative density of the metal is 8, which means it's 8 times denser than 1. Understanding density and relative density is crucial in various fields. For instance, shipbuilders need to ensure their vessels are designed to withstand the density of seawater. Oceanographers study the density of ocean currents to understand global climate patterns. Let's look at some everyday examples of relative density. A huge metal ship floats in the water because its overall density is less than that of water. The ship's design with a lot of air inside reduces its average density. An iceberg is another example. Even though it's made of ice, which has a density greater than water, most of the iceberg's mass is below the surface, meaning only a small portion of it is visible above the water. To wrap it up, density is a measure of how much mass an object has in a given volume, and relative density compares an object's density to the density of water. These concepts help us understand why some objects float while others sink. Thanks for watching. Stay curious and keep exploring the world of science.